balance the redox equation by that is in basic solution. Okay, that's why I called it redox basic. And this is the equation. So what do we have to do in the first place? The first place, it is still mandatory to do. That is to write or to find the oxidation state of each substance that is in the reaction. Okay, so here we have, this is an ion, this is a compound, this is a compound, and this is also a compound. Okay, now remember the rules that says for oxidation number, it says the ion is equalized to the charge. Okay, so I want to know what the charge of chromium is. Okay, remember what I do, the math that I do. Remember the math trick that I do? I say, okay, I say 8 minus 2, and that gives me 6. Okay, so chromium here is going to be 6. Do you remember how I do it, right? I'm going to do it apart, the review. So, you know that the oxidation state of oxygen is -2. We don't know what the chromium is. So, mentally, what I do is I say -2 times 4 plus 2, and that gives me -6. And then I just get rid of the negative, and I take the 6 as part of the chromium oxidation state, plus 6. Okay? Because plus 6 minus 8 gives me -2. That's the purpose of it. But that only happens when you have an ion, okay? And here in the compound, you see this 2. This 2 tells me the charge of what element? This 2 gives of iron, okay? So iron is going to be plus 2. Remember the rule of oxygen, that is -2, and the rule of hydrogen, that is plus 1. This 3 tells me the charge of what element? The 3 tells me the charge of what element?
Chromium.
Of chromium. So chromium will be plus 3, oxygen will be -2, and hydrogen will be positive 1. Okay? Now, this 3 tells me the charge of what element? This 3 tells me the charge of what element?
Iron.
Iron. So iron will be plus 3, oxygen -2, and hydrogen plus 1. Okay? Okay. And with this, we finish the first part that says that we need to get the oxidation state of each compound, of each element, sorry. So, right now we need to identify what element is being oxidized and what element is being reduced. What element is being reduced? What element is being reduced?
Chromium.
Chromium. So here in chromium, you know that a reduction took place. Okay? Now, what element is being oxidized? What element is being oxidized?
Iron.
Iron. So, between the iron, I indicate that I have my oxidation. So there I have my redox, and what I do is I take them apart. Okay? I take them apart, and I write my redox right in here. Okay, so I'm going to write my reaction, my half reaction for reduction that goes between the iron chromate and this is producing chromium 3 hydroxide. The oxidation occurs between iron 2 hydroxide and this is producing iron 3 hydroxide. Okay, these are my half reactions, but they are incomplete. So the rule says that you need to balance the amount of oxygens by adding water. Okay, so here you have how many oxygens. In the reactants, in the redox, we're working just in the red, in the reduction, okay? In the reactants, here I have 4 oxygens, and here I have 3 oxygens. So, the rule says that I need to balance oxygen by adding water where I need it. So, I need oxygen here. I need oxygen. If I need oxygen, I will add water. How much water am I going to add? If I need 1 oxygen, I will add 1 molecule of water. If I need 2 oxygens, I will add 2 molecules of water. Okay? So the amount of oxygen that I will need, I'm going to add water instead. So I just need 1 oxygen, therefore I'm just going to add 1 water. Okay? And now, my oxygen, sorry. ¿Qué pasó? I'm just going to add 1 water. Okay? So the equation will be like that. But now, as you can see, here I have hydrogen, and in the reactants I don't. So the rule says that to balance hydrogen, what I need to do is I need to add hydrogen plus ions. Okay, so how much hydrogen I need to add in the reactants to make it balanced? Here I have 3 hydrogens. Here I have 2 hydrogens. How much hydrogen plus ions then I will need to add in the reactants?
5.
5 hydrogen plus ions, okay? So I'm going to write plus 5H plus. Now, remember that after we balance the oxygen and the hydrogen, we need to balance the amount of electrons. Now, let's take a look to the charges, okay? In the charges, I have 1 chromium. I'm going to move this down just for a moment, okay? I have 1 chromate, so it's 1 times a charge of -2. And I have 5. I'm going to add the charges, okay? So here is my charge, and for hydrogen I have 5 that has a charge of +1. This is because of the charge that is above. Now this is going to give me -2 plus 5 in total plus 3. Okay, so my charge here is +3, and in the products I have 0 because they are compounds. So +3 produces 0. To balance the charge of 3, I will need to add electrons. Where do I add electrons? In the reactants or in the products? In
Product.
reduction. In reduction, where do I need to add the electrons? In the reactants or in the products?
In the product.
In the reactants. Remember that charges, the electron had negative charges, okay? So, if you had a charge of +3, but you add 3 electrons, electrons is like having a charge of -1. So this is going to balance up to 0. That's why we add the electrons in the place where we have the number. That's why it says reduction gains electrons. Okay, gains electrons. Okay, or electrons in the reactants. So how many electrons? +3, so +3 electrons here. I'm going to get rid of these calculations. Okay. Now in my products, sorry, I need to work also with my with my oxidation. Sorry. With this, everything is balanced. Okay. With this, everything is balanced because you have +3. Okay. -3 gives 0, and in the other side you also have 0. Now in the products, I have take a look. I have 0 because it's a compound. That's my total oxidation state, and I also have 0 in the products. So the charges are going to be balanced so far, okay? But we need to balance oxygen. Here I have only 2 oxygens, and here I have 3 oxygens. So where do I need to add water? In the reactants or in the products?
Reactant.
How much water I need to add? 1 or 2 or 3 molecules?
One. No, no. 2.
I have 2 oxygens in the reactant, and to have 1 more oxygen, I need to add 1 water. Remember this. My amount of oxygen, remember how much oxygen do you find in a molecule of water? Just 1 oxygen. That's why if you need to balance oxygen, just 1 water is required. So you say plus H2O, and now you will have 2 plus 1 oxygen, okay? 2 plus 1 oxygen equals 3 oxygens. Now, in the oxygens, in the hydrogens, I have 2 hydrogens plus 2 hydrogens. That makes 4 hydrogen in total. In the products, I have just 3 hydrogens. So I need to add hydrogens where? In the reactants or in the products? Where do I need to balance the hydrogens?
In the product.
In the products. I just need 1 more hydrogen, so it's going to be 1H plus. So now it's going to be 4 hydrogen equals 4 hydrogen, so it's balanced. My oxygen and hydrogen, now it is balanced. And if you take a look, the charges now are different, because here you have 0 plus 0, the total charges that you have is 0, producing 0 plus 1, okay? So it's not balanced, the charges are not balanced. How many electrons and where I have to add in order to oxidation to be balanced? In oxidation, where do you write the electrons? In the products or in the reactant?
In the product.
in the product. And because you have a charge of +1, that means that you will need to add the same amount of electrons. So plus 1 electron that has a charge of -1. So 1 minus 1 is going to give you 0, and 0 equals 0 means that it's balanced. So in other words, here you need to add your number of electrons. 1 electron, and it's going to be balanced. Not just the elements, but also the charges. Now, in order for everything to be balanced in the end, you have to cross multiply. Okay? You have to cross multiply because the number of electrons, remember, they must be balanced. So by what number do you have to multiply the second reaction to eliminate the number of electrons?
3.
Times 3. Okay? So I multiply this times 3, and the first one I will multiply times 1. But you know that multiplication times 1 is really, you don't really need it. Okay? You don't really do it. So we're just going to make the second equation. Now, as a result, we're going to have the reduction is going to be the same. We're going to have 3 electrons. We're going to have chromate. And we're going to have 5 H plus ions producing the rest. And in the oxidation, now here it's going to be different because we're multiplying times 3. That means that this 3 is going to multiply everything. Okay, it's going to multiply everything. And I know that it looks messy, and I will erase it. But just remember that 3 outside multiplies everything inside. So here you're going to have 3 oxygen, 2 hydroxide, plus 3 waters. All this is producing 3 iron 3 hydroxide plus 3 H plus ions plus 3 electrons. I know this process is long. I know it. Now what we do is we add everything. We add everything together. Here you can directly cancel the electron. That's what I really do, okay? In this step, I really cancel the electrons in the reactants with my electrons in the product, okay? And I'm just going to write everything together with the same coefficients that they have. Okay? So this is going to be so I just put everything together, okay? Everything in the reactants and everything in the products. Here you can do it exactly without the electrons because they were already cancelled. Okay, so in this point, we need to do a few things in this point, okay? Take a look. You will notice that water is repeated in the reactants and also in the products. Okay? And you will notice also that hydrogen plus ion is repeated in the reactants and also in the products. Now, what we do is we subtract them because they are in opposite sides. Remember, this arrow separates reactants with the products. So that means, if they were in the same place, if I had, for example, a 2H plus here plus the rest, then you add them because they are in the same position. You add them because they are in the same reactants. But here they are in opposite sides. It's like in an equation, okay? In a mathematical equation, for example, 2x plus 5y plus 3x equals, I don't know, 20x minus 10y. For example, in math, what do? You notice that you have like terms, so you add them, okay? Because they are in the same side in the reaction in the equation, okay? So you will have in total 5x plus 5y equals 20x minus 10y. That's a way that we call this is what we know as like terms, but when they are in the same position. In this case, they are in different positions. Because they are in different positions, we're going to subtract them. And you're going to write the result where you have the greatest number. So for example, here you will subtract minus 3h plus minus 3h plus. Okay? And with water, it's going to be the same. Minus H2O minus H2O. So what is going to happen here is that in these terms, because you are subtracting the exact same number, they are going to be eliminated. 3 minus 3 is going to give you 0. And plus invisible 1 water minus invisible 1 water is also going to be cancelled. So those terms are going to physically disappear in the products so far. And in the reactants, you're going to perform the subtraction. You're going to perform the subtraction. So here you have a plus 3 waters minus 1 invisible water. So what is the result of this subtraction? 3 minus 1 is going to give you 2 waters. 2H2O as a result. And in here, 5H plus minus 3H plus is going to give you as a result 2H plus. Okay? Then what you do is you continue, you copy the rest of the substances. You have 3 iron 2 hydroxide, you have chromate ion. This is producing what you have in the products, okay? 3 iron 3 hydroxide plus chromium 3 hydroxide. Remember that these terms were cancelled. I think it's just with one L. Yes. Well, their elimination occurs. So, now the rule says that for every in the place where you have H plus ion, you need to add hydroxide, and this is where basic begins. So the part says that it doesn't matter the amount of H plus ions that you have, you're going to add as much as OH minus ions. So take a look, because here you have two H plus ions, you're going to add OH minus, okay? But what you do in the right must be done in the left, okay? So you're going to add two OH minus ions in the reactants, but also in the product. And then another rule appears. This rule says that OH and H plus, when you combine them, the two of them are going to produce water. Okay? So here, these two are actually going to produce water. So 2H minus plus 2OH minus plus 2H plus is going to produce 2 water, 2 more water. Okay? So this equation now is changing to now I will write the combination that we got, 2H2O. All this is producing what we have in the products. I will leave this in blue. And here, as you notice, again, we have like terms. We have 2 water over here and also 2 water over there. And the rule says that when you have the same substance in the same side of the reaction, we have like terms that need to be added. So we need to add them, okay? Because we have like terms, we need to add them. So 2 plus 2 is gonna give you 4 waters instead. So the final reaction will be 4 plus 2 plus 2 makes 4 waters, and in the products I'm going to write what I had before. Because I'm a lazy one, I'm just going to copy and paste. And what we do after is we do a final check. We check that everything is balanced by comparing the amounts of each element in the two sides. So here I have iron, I have chromium, I have hydrogen and oxygen. And then we start counting the number of atoms. We have, as you can see, we have 3 irons in the right and 3 in the left. We have 1 chromium in each side. We have hydrogen, we have 3 times 2 that makes 6, plus 4 and 2 that makes 8. In total, we have 14 hydrogens in the reactants, and in the products, we have 3 times 3, that makes 9, plus 3, that makes 12, plus 2, that makes 14. And then in oxygen, we have 3 times 2, plus 4, plus 4 times 1. In total, I have 6 plus 4 plus 4. That makes also 14 oxygen. And in the products, I see that I have 3 times 3, which is 9, plus 3 plus 2, which is also 14. Now, as you can compare, what you have in the reactants is exactly the same as what you have in the products. Everything matches. So we say that it's balanced. But remember that we do also a final check of the charges. We also check the charges. So here we check the atoms, and here we check the charges. Now for the charges, we have, because this is a compound, the charge is 0. Here we have -2, and here we have 0. In the products, we have 0, we have 0, and here the charge is 2 times -1. So we compare the charges, we have 0 minus 2 plus 0, producing 0 plus 0 plus 2 minus 1. So this gives me -2 producing -2. It is balanced. We have the same amount of charges. So we can say that this equation is balanced by the number of atoms and also by the charges by using the basic redox procedure. It's long. It is a really long process. Redox was nice for balancing equations, but now that it's basic, it's a lot more procedure. So please, if you need, watch this video again to have a better understanding on what I did in each step. This topic requires that you study a little bit more, okay?